enjoyed the biology. Like I still like biology. I mean, still breed dogs and stuff. I enjoy it.
I mean, I'm just a
Let me know
freshman,
if you need a
so
hand with that.
haven't gotten into
Hello.
anything
Yeah,
particularly.
because microphone.
Thus far.
I'll throw the math at her.
I can do this. So you have to isolate for one of the variables, and then you plug it into them both, and then
Oh, so you're
you
doing
Yeah,
substitution.
yeah, we'll make sure that
You can
Donia's is
make
working
something
also, so that.
eliminate, right?
So you can cancel all
Okay.
the X's, and then.
Two. But then they did this minus this to make the x. So it's like they had to make the x cancel for.
Yeah, so you have to get rid of one variable and then solve for that system with
Yeah.
the two.
Right.
And then you would
But is this
input it
5, 4,
This is the
3,
correct way, right?
2, 1.
as long as it goes on nice.
And make sure when we get going, you are loud. You have important stuff to get.
Yes.
You just kept a 5 for us, so we can get this.
1, 2, 3, 4, 5.
Yeah, we're gonna get her in a picture, right?
Thank you.
Most of the time. Facing that way so they can see. At
Hi.
the beginning, you're gonna be looking at this camera, because you're gonna read.
Yeah.
All right?
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And in studio with us we have Deborah. And Deborah, if somebody needed to get a hold of us, what would they need to do?
In Bakersfield, 636-4357. Toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right. That stuff is all over the place, isn't it?
Yeah.
All right. A lot of ways to get a hold of us. But first, before we get going, why don't you let everybody know where you go to school and what grade you're in?
I go to Ronald Reagan and I'm in 6th grade.
What's the worst thing about being in 6th grade? Because there's a lot of good things, I'm
It's
sure.
a lot of different than 5th grade.
But
It's
what's
a
the
big
worst
jump.
thing about it? Like if you
math.
could say, oh, you don't like the math in 6th grade, huh? That's the
It's
worst
a
thing?
bit different
It's a
than
bit
5th
different.
grade.
Well, you know what? It's a bit good for you then, so that it's not so easy. Because guess what's going to happen when you go to junior high next year?
It's going to be harder.
It's going to be a bit different. It may not be more difficult, right? Because you may learn a lot this year and get you ready for next year, right?
Yeah,
All right. Do you know why you're here?
to learn math.
And to show us how you do math. Are you ready?
Yeah.
All right, over to the board. You and Cindy are going to work on this first problem. This is a proportion problem. A casserole recipe serves 12 people. So you write down any information you think you're going to need. So the recipe serves 12 people and calls for 3 cups of spinach. If you want to adjust the recipe to serve 18 people instead of 12, how many cups of spinach should you now use?
So right now you see that there's 6 more. So what's 12 divided by 3, which would be 4?
So what would that tell us?
It would say how many cups per, or how many people per cup. So per cup, you know, it's 4 people.
Okay.
So that's correct. And I would do 18 divided by 4, but then you would also get a remainder. But 18 divided by 4. So you would need 4.5, or no, it would be 4.5 people per cup for that, if you see what
Well,
I'm
so
doing.
this was our people, right? This one?
Yeah.
And this was our cups, right?
Yeah.
So if we're finding this part and you got 4.5, that's actually going to be that measurement. So 18 people would need 4.5 cups
Yeah.
of spinach, right? With spinach?
And then think about it, right. So think about it reasonably. Like, okay, you've got 4.5, you have 4.5 people
Yeah.
that are going to
That's
do
not
anything
gonna
with this, right? Okay, because it sounds kind of weird, right? So does that make sense?
No.
So it's like, okay, so let me just like,
Because you
okay.
know it's not going to be people.
You have 12 people needs 3 cups. So if you have 18 people, you need some amount of cups.
Yeah.
So whenever we solve for that missing piece, it's really the cups that we're solving for.
Yeah. You want to see 12 times what is 18? Is that what? And then you
Oh, yeah, I
want
said
to
it a bit different
multiply
then.
that by 3 times.
Yeah.
That
So you
number.
did that divided by that is 4. So you figured out it's 4 people for a cup.
Yeah.
And
Right,
got
so there's different ways
4.5,
to solve
you know.
that problem.
Okay, so you can't multiply 12 by something and get 18, right? Well, you can, but it's
Yeah,
not going
that's
to be a whole
gonna be
number.
hard.
So you can cross multiply like this and then
Yeah.
solve. Well, not cross cancel, like actually multiply. So you do 3 times 18, because there's like an equal sign right here, so it's not the same as just a multiply where you
okay.
cross cancel.
So 12 times 18.
Well, okay, watch. Have you done proportions?
No.
This is proportion. So it's kind of like, okay, so say if you had 1/2 and you know that's the same as 3/6,
Yeah.
right? If you multiply, they're the same value.
Yeah.
So you get 1 times 6 and 2 times 3, and they're equal. So whenever you have a missing part and you can't just easily see the relationship.
So 3 times 18.
Yeah, so you multiply 3 times 18. Okay, so 54, and then you're going to put equals, and then you're going to do 12 times x.
Yeah.
Which is just 12x, right?
Yeah.
And you've been, do you have Mr. Kushine?
Yeah.
So I know you know how to solve that equation, right?
Yeah.
Okay, so this is actually, like, this answer is going to be this side. This is actually going to give you the same answer you got up here, though. Okay, so how would you get the x alone? How'd you get rid of the 12?
So you would divide by 12.
Yeah.
And then you'd
And
have
then
to
you
do
do-
54 divided by 12.
Yeah. You're still going to get this, just so you know.
So 12 times what is 54? My estimate would be 4.
Mm-hmm.
That'd be 8. That 4. And there would be a remainder of 2, 6,
Mm-hmm.
which wouldn't really work out.
So if you did like this, right?
Yeah.
Right? And you divided that, and you got 4 here, and you had your remainder, then you would just go like that to get your.
So which would
You're
be
still going to get
5.
that. So the only thing up here is you were just saying the label wrong. Because when you solve it and you get 4.5, it's really this part.
Okay.
So it's cups instead of
Yeah.
people.
People.
Yeah.
There you go. And
See,
as
that
we
way
saw,
works.
a
Totally, you just got
couple
the wrong label.
of different ways to do that proportion problem right there. Hey, we do have phone tutors available until 5:30 this afternoon. The phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News.
I'm so smart, aren't I?
You are. It's okay.
All right, today's Math in the News has to do with baseball. Do you like baseball?
I didn't really watch it, but
Okay,
yeah,
so
sure.
you're like, all right, I like baseball. I don't really care one way or the other, right? All right. So anyway, CSUB Athletics Department is a big sponsor of Do the Math, and we've got tickets to hand out to kids that are on the show. One of the games that happened a little while ago, a couple of weeks ago, was a baseball game where Holy Cross came into town, and this is the box score for the game before that. So we can see that you have all 9 of the players, and then at the bottom you have the starter, the guy on the mound for that afternoon. So they have a lot of different statistics that you can look at in baseball. And what I figured we'd do is we would take a look at the ERA. So if we focus in on one of these, we can see that the ERA, the earned run average, is 18. This is the wins and losses, so they have 0 wins and 2 losses. 2 appearances, 2 games started, 4 innings pitched. They gave up 4 hits, gave up 8 runs, 7 bases on balls, and 2 strikeouts, and the batters were batting .353 against them. So that person was having a difficult time. The ERA you want low. So if you can get it around 3 or lower, that's going to be good. So we have here an example of a major league pitcher who recently retired, Mariano Rivera from the New York Yankees. The reason we bring him up is because he's the only person in Major League Baseball history to be inducted into the Hall of Fame with a 100% vote of all the writers. So a lot of times somebody may miss it by a couple of writers. They'll go, we don't want to make them 100%. We'll give them 99.6% or something like that, but we won't give them 100%. He is the first person in all of Major League Baseball to get in on 100%. So I figured what a great example to have. So next, here's how to do the math on how to figure out the earned run average for somebody that is on the mound. There are two different methods that we can see. I think the easiest one is the second method, where we take the earned runs times the total innings. So the total innings is the number of innings in the game divided by how many innings they were on the mound. So we can see the example that 3 earned runs times 9 innings, because there are 9 innings in a baseball game, divided by the 6, how many innings he was on the mound. So you would go 18 divided by 6, or 27 I mean, divided by 6 and you get your 4.5, so the ERA would be 4.5. Does that make sense?
Yeah.
There you go. So when you're at a baseball game sometime, you can figure out the earned run average, you can look up and go, oh, well, that's how many runs they gave up, this is how many innings they pitched, and then maybe you'll like baseball a little more. Who knows? But anyway, it'll be fun to go and try it out sometime. That is today's Math in the News. 636-4357 is that phone number. We do have phone tutors available until 5:30. Deborah, a 6th grade student from Ronald Reagan Elementary, is in studio with us doing some math today. How long have you been at Reagan?
Since kindergarten.
Since kindergarten.
Yeah.
All right, so you've been there for 7 years.
Yeah.
Do you think there's going to be anything that you'll miss next year? Because you'll be at a new school for the first time.
I really like all my teachers and all my friends, and a lot of people are going to different middle schools, so it's going to be a bit different.
It'll be a bit different.
It'll be fun.
That's right. That's the positive way to look at it right there, okay? Look on the bright side of things, right? All right. You know what? We had an opportunity to go to another school, actually Bakersfield College, and visit with the folks that do a little bit of industrial drawing.
It is time for Math in the Real World, your favorite part, my favorite part of the show, where we answer that age-old question, where the heck are we going to use this math stuff? So we're here today at Bakersfield College with Darren Willis. Thanks so much for your time. I appreciate it.
You're welcome. Thanks for coming.
Where are we and what's going on? Because we know there's some math going on in this room.
So we are in the MS-10 CAD lab. We have 2 labs for computer-aided drafting and design. The industrial drawing program shares them with the architecture program.
Okay.
And the students are out working on drawing problems that would be typical for working in industry. So right now they're getting some basic CAD training so that they can go into drawing files and edit them. The idea is if they want to continue in this pathway, they can take specialized classes that give them more skills, expose them to things like electrical design, piping design, civil drafting and surveying, and then find employment at a nice high rate of pay. Students can leave our program after 2 or 3 classes and get a really well-paying job. Ones that want to stick around for an associate's degree, well, they do even better because they have more experience and more training.
Right.
And then students that want to transfer also get to go on to Fresno, for example. They can complete a 4-year program if they want to. So we've got something for everybody. We've got things for people that want to be here for a short amount of time, for a couple of years part-time maybe, a couple of years full-time, or if their ultimate goal is university, they can start here and launch from here too.
So many options. And this is all technical drawing stuff. So any project, plumbing project, electrical project, building project, has to have a set of plans. We know that. We've seen that in previous sections. You got to have a blueprint and whatever, but you got to be able to draw that blueprint. So that's kind of what we're doing, right? We're drawing specific pictures with deliberate dimensions and all those things.
Sure. We have an electronics department. We have welding. We have manufacturing, we have construction, we have woodworking, we have automation. We have all those different technical areas here on campus for students that want to get trained in those. But the one thing they all have in common is they all need blueprints. They all need drawings. So it's kind of nice because we get to work on a variety of different things, and you can specialize in a specific area that's really attractive to you. And it's nice to have the flexibility to go from one area to the other with minimal retraining, because you've got the basics of understanding technical drawings and graphics and how to use the 2D and the 3D software.
Right. How did you get involved in this? What's your interest in this stuff? Were you in the profession for a while before you started being a teacher?
So my background is industrial. I was on the East Coast. I was in construction and cabinet making, actually. And that turned into design building, and I learned CAD, and we did projects where we would design and then build the project.
Right.
When I moved to California in '99, I thought it was time for a change and got into the teaching career. There was an opportunity at Highland High School. I taught there for 10 years, and then there was an opportunity up here to move up here about 10 years ago.
Right. Wow, what a neat deal. So you really have some in the field experience. And
Little bit.
Yeah, well, that's got to be so helpful for your students. So just as an example, looks like you have something pulled up here. Show us a little bit about this project and where it starts, where it goes. And obviously it looks almost like a finished product. It's nice and colorful and everything, and we can see there's some pipes, but obviously it doesn't start like that, right?
No. So this is a piping project, and the project is in 3D. We use the 3D stuff a lot of times to train the students on how to interpret the 2D drawings, because typically we're not going to get pictures like this on a set of plans. We're going to want to look at top view, side view. We're going to look at sections and elevations and arrangement drawings. So ultimately the goal is for students to learn how to do piping in 3D, but they have to have a good foundation. It's like anything. We can't use the fancy tools and do the cool stuff until we understand how the fancy tools work and why they do what they do. So the students will use this as a basis for setting up arrangement drawings, for setting up elevations. They've got to be able to work at different scales. They've got to be able to look at charts that show sizes of valves and pipe and different schedules of pipe thickness. And they've got to take all that information and put together a set of working drawings, a packet of drawings at the end.
That would work in the real world, right?
Sure.
So just as a tidbit, and I know we'll get to more of this later, but where does the math come in? Because obviously the computer's doing a whole lot of math, but the student, you said, has to know about the thickness of the pipe, right? Or the size of the valve, or the length of a certain run of pipe, or whatever it is. Any other math they have to do in there that they have to like calculate?
A lot of the calculation is done before the CAD models are made.
Okay.
So
like
we
you
want
said, you got to do the tough work sometimes.
As an
before you get the
example,
drawing.
if I look at the top of the facility, this vessel over here has a line coming out of it that goes into the vessel over here. And of course, they need to be lined up with each other.
Right.
And the two nozzles need to be aligned.
Yeah.
And they need to be able to calculate the locations of that in order to be able to put the drawings together correctly.
Right.
So it's not high level math. We do a little bit of algebra, a little bit of trigonometry, but with that basic functions, with fractions and decimals and working back and forth, and the ability to manipulate things very well, you can really go far with this.
And heck, maybe even make it make sense, right? Before they actually get the final product. So we're going to see some more about what's going on here, because you can tell there's all kinds of stuff happening here. Right now we know there's some problems to do back in the studio, so we'll go back there.
All right, thanks for that, Scott. Also, thank you to the instructors over at Bakersfield College helping us out. We do have phone tutors available until 5:30. We have Deborah, a 6th grade student from Ronald Reagan Elementary, in studio with us right now, and you're about to do some more work. So this isn't even your homework, is it?
No.
This is bonus work, so this is great. So you have regular do you have a lot of homework normally?
No.
Okay, so it's good that you have this bonus work to work on, right?
Yeah.
All right, good. So let's take a look at this problem that Deborah's going to start working on. So I'll let you two ladies go ahead and go over to the board, and we have 3x plus y plus 2z is equal to 1, negative 5x minus 3y minus 2z is equal to 5, and our third equation, negative 9x minus 6y minus 2z is equal to 13. Deborah, please instruct us as how you would like to solve this.
So this is how I do it. I say that this one is the first equation, this one is the second, and this one is the third. From other ways, you want to cancel them out. So I'm going to do 1 and 2 first. 1 is 3x, positive y, and positive 2z equals 1. And you have negative 5x, negative 3y, and negative 2z. Equals 5. Since you have two of the same, you have a 2z, a positive 2z, and a negative 2z, and you want to cancel them out. So you can add them together. So I would do 3x plus negative 5x would be negative 2x y with a negative 3y would be negative 2y. These two would get canceled out, and this would be negative 4.
So are you adding or subtracting?
I'm adding.
Okay, so check that one then, because you subtracted on that one.
Oh.
So you got the z's to cancel on those two equations so far.
So I'm gonna put 1 and 3 now. You have,
So let's call this 4 just for future, so
Okay.
we don't get mixed up later.
and we have 3x, positive y, positive 2z equals 1. And then number 3 is negative 9x, negative 6y, negative 2z equals 13. Since we have the same z's, they're both 2, we're gonna add them together. 3x plus negative 9x would be negative 6x. This would be negative 5x, or 5y. These two would get canceled out, and if you add these together, it would be 14. Now we're gonna put this as 5.
So number 5. Okay.
And we're gonna put these two together. Right?
Okay. Because now we want to get something else to
Yeah.
cancel, or, so we can figure out what one of the variables is, right?
Can I erase this?
So we can move this down actually a little bit, and we can come back
Okay.
up to it that way if we need it.
So we have negative 2x, negative 2y equals 6 as number 4. And then for number 5, we have negative 6x, negative 5y equals 14. So we don't have any in common right now, but if we want to find one together, you can multiply this one by 5 and this one by 2.
Okay, so I'm just gonna stop, pause for a second, only because I noticed this. I can make that become a 6 easily, right?
Yeah.
So it's easy, it's just a little quicker, because
Yeah,
then
that
you don't have to
would.
do both of them. So we can make the
So-
x's cancel instead on this one, right?
Okay. So this multiplied by 3 would be negative 6x.
So
Multiply,
I'm just gonna write it so people know what we're doing here, right? Okay.
multiply this by 3 would be negative 6y. Multiply this by 3 would be 18. And we're just going to bring that one down. So for this one, we're actually going to subtract, so we could cancel these two together.
Okay.
Negative 6 with negative 5, negative 6y with negative 5y would just be negative y. And these two subtracted would be 4. So I'm going to put the subtraction sign on the other side because we always want the y to be positive. So we know that y equals positive 4.
Okay.
Or minus
Now, what are you
4.
going to do with your negative 6 and negative 6?
Whoops.
So now we're going to put this in.
Are you asking about this part?
Yeah, I'm not
Right.
done yet. So
Okay.
I'm going to put we have negative 6. I'm just going to do the top one because I feel like it's easier. Negative 6x. We figured out that y is negative 4, so plus positive 24.
And that's because you did negative 6 times
It's
negative 4. Okay.
And minus by minus is positive equals 18. We're going to bring this on the other side, so it's going to be a negative. With this together, it's going to be negative. When you put these together, it's going to be a negative 6
Okay.
equals negative 6x. we're going to make these both positive, and then x is equal to 1.
Okay. So now we have x and y. What else do we need though?
We need the ones on top
So we got to go back and
get z.
because we still have to find that third letter, right?
Yeah,
so
Z.
do we have anything where,
We can do it
I mean,
here.
you can just plug it in pretty
Yeah.
much, right? Because you know what x and y are now.
Yeah, so we can put
You want to do the top one
x
because there's less
is
negatives?
1. Yeah, x
Okay.
is 1, and 1 times 3 is 3. Y is 4. Wait, wasn't it negative 4?
For the y? Let's see. Was it? I think it wasn't though. I think because remember it had. Oh, it was. You're right. All right. Good catch. Okay, so negative.
Can bring it a bit higher.
Okay, so y is -4. So
So y is going to be -4, which and positive 2z
and then that's the one we're solving for now, right?
equals 1. Yes. So we're gonna put the variables on one side and the regular numbers on the other. This is gonna be -3 and this is gonna be +4. So 2z equals +4, +1, -3. 4 plus 1 is 5, minus 3 is 2. So 2z equals 2, z equals 1. And then there's a way to check this. Should I check it?
Yeah, we should probably. Well, we have enough time to
Right.
check it?
Well, you know what we're going to do? We're going to let you check that in a moment. But for some great work right there, we're going to award you with a meal courtesy of our friends at Chick-fil-A. So congratulations on that. Hopefully you have an opportunity to go check that out. I can tell you that it is mighty tasty. So hopefully you get an opportunity to head over there. We do have phone tutors available until 5:30. We're going to clear the board. You know what? Add a page. There you go. Deborah, come on over here because right now we're going to go to the phones. And Haley, a 6th grade student, is on the phone. Haley, how are you today?
Good.
What kind of math problem are you working on?
What?
You can just say the math problem that you're working on whenever you're ready.
My problem?
Yes.
Okay. So, if 1/6 of 400 equals 5/6 of x, what is the value of x?
So 1/6 of 400, is that what you said, or 1/5?
1/6.
1/6 of 400, if 1/6 of 400 equals, okay, say the next part.
5/6 of x.
Okay,
What is the value of x?
okay. Okay, so have you started? Have you approached the problem already?
I couldn't quite understand it because I've never actually done one of these problems before.
Okay, so when I look at it and I see that it says 1/6 of 400, I can actually, you could calculate that, can you?
It's 1/6 times 400 over 1, right?
Right, exactly. So let's go ahead and figure out what that is. So what is 1/6 times 400 over 1? Okay. So we could cross cancel, but I'm thinking it might be better just to leave it with a 6 since the other side has a 6 already. So let's just do that equals 400 over 6.
Okay.
Okay? So 400 over 6 is equal to 5/6 of something, yeah?
Yes.
Okay. And how are you guys, have you solved equations already before?
Like the ones with variables?
Yeah.
Yes.
Okay. So if we change the 5/6 of x and we change that word of and we just make it a multiply, right? So we put 5/6 times x. Do you know how to solve it when there's a fraction with your x?
Kind of.
Okay, tell me what you know and then I'll just correct you if you're not sure.
I think that you have to put like a 1 underneath the x
Okay.
and then
So let me ask you this question. If it just said 5x instead of 5/6x, what kind of math operations there? Is it?
Multiplication.
Okay, so right now it's still a multiplication. It's just a multiplication by a fraction. So it's 5, 6 times x, right?
Mm-hmm.
So technically, we do the inverse operation, so we do division, but we're dividing by 5, 6.
Yes.
So the rule that when you divide by a fraction, you really multiply by the reciprocal, we're going to use that.
Okay.
Okay, so what you would do here is you would multiply by the reciprocal of 5, 6. Do you know what the reciprocal of 5, 6 is?
6 over 5.
Okay, good job. I was kind of testing you to see if you knew that word reciprocal. Okay, so we're going to do that to both sides. Okay, so I'm going to erase some of this right here. Okay. Okay, so we're going to do multiply the left side, which is the 400 over 6 right now. We're going to multiply it by 6 over 5. And then on the right side, we multiply it by 6 over 5. So we'll get the x by itself because the 5 and 5 will cancel and the 6 and 6 will cross cancel. So all we need to solve now is the left-hand side. Are you watching?
No.
Okay, so on the left I have 6 over 5 times 400 over 6. So I need to cross cancel there. So cross reduce, I can reduce the 6's. What would they become?
1.
Right. And then can I divide the 400 by 5?
Yes.
Okay, so what will I get?
80.
Good. So that means that x equals 80.
What?
That means that the x is equal to 80.
Yes.
Does that make sense to you, Haley?
Yes.
All right, good. Well, a great problem right there. You've got yourself a meal courtesy of our friends at Broken Yoke, so congratulations on that. We have Deborah in studio. We'll have her doing some more work. We'll visit with BC again, and we have a special guest coming up later on. We'll do it all right after this. Today we're at Mojave Elementary, home of the Colts, and we're here to Once again, we're with the 4th and 5th grade students at Mojave Elementary. You guys ready?
Mm-hmm.
So we've a lot of work that we've done with positives and negatives, okay? Now we're going to put it into a game form, and we're going to see who can correctly get a bingo first before everybody else. So in each of these boxes, you're going to put a number that is between 20 and negative 20. You can also put 0. 0 is a number. There are no free spaces on this like there is regular bingo. So you're just going to start putting in numbers. So I'm going to put a 0 there. I'm going to put a 1 there. Maybe I'll put a -3 right there. I'll put 10. You guys see how it goes? You got to put positive and negative numbers in there. But you can't go any higher than 20. And you can't go any lower than -20. Okay? You ready? Go. Fill them in. Any numbers at all that you want. Positives and negatives. Are you guys ready?
Yeah.
Okay, so what I want you to do is if I say a problem and you have the answer to it, just mark your paper, like put an X on it or something, all right? Circle it, however you want to do it. When you get 5 in a row, what do you say?
Bingo.
You guys know how to play, right? Mm-hmm. Here we go. -7 minus 7. Now, if you guys need to, take out your number lines.
Can we use this?
Well, that's when you multiply and divide, right? So right now, if we're at -7 and we're going to subtract 7 more, are we going to get closer to 0 or farther away? Farther away, right? So if you're at -7, go backwards 7 more. So -7 minus 7. And where will that put us? Negative 14. So if you have -14, go ahead and put an X on it or a circle. I'll keep track of which ones I'm calling here. All right, here we go. Next one. 8 minus 6. All right, so we know that it's 2, so see if you have a 2. If you have a 2 on there, go ahead and circle it or mark it. All right, next one, -2. So if you need to on the paper, find -2 plus 10. So if you're at -2 and you're going to add 10, so you're going to get a larger number, right? You're going to go past 0. So you're at -2 and you're going to add 10. Well, you're going to go forward, right? Because you're at -2 and you're going to add 10. So we're going to go in the positive direction. So if you're at -2 and you add 10, where do you end up at?
+8.
+8, okay? So -2 plus 10 is the same thing as 10 minus 2. So we know it's 8. So go ahead and circle an 8, or X it off if you have it 8. 11, so listen to how I say that. So we are at 11, and we're going to add -11. Where will we end up at? 0, right? So if we're at 11 and we're going to add -11, it's the same thing as 11, take away 11, right? So 0, if you have 0, go ahead and mark it. All right, -4. So go ahead and think about where -4 is, or if you need you to use the number line, put your pencil or finger on -4. -11. So if you're at -4, you're going to take away 11 more. So you're going to move 11 farther away from 0.
That would lead us at -15.
-15, right? So if you're at 4, -4, and you're going to go negative, right? You're going to go to the left. You're going to keep going 11 more. So you end up at -15. So if you have -15, mark it on your paper. I bet you guys all had +15, didn't you? Not -15.
I didn't even put 15 down.
You don't have 15 positive or negative? All right, we'll see if we can find one more. All right, 4. So we're going to start at 4. +4. Take away 9. So you're going to go to the left, -9. So if once you're at 4, go back 9. So let's see how everybody's doing. So if you're at 4 and you go back -9, where do you end up at? -5. So -5, go ahead, mark it, circle it, or exit.
I forgot we needed to do 5 in a row.
Oh, you've got 3 in a row, right? That'd be tic-tac-toe if we were doing that, but we need 5 in a row for bingo. So we'll continue playing with the 4th and 5th grade students at Mojave Elementary School.
Do the math! Yeah!
The students at Mojave Elementary, a pleasure to work with once again. We do have phone tutors available until 5:30. We have Deborah, a 6th grade student from Reagan Elementary, in studio with us doing some great math problems. We also have another opportunity right now to go out and visit Scott. He's at Bakersfield College.
Back to math in the real world. You know there's math out here, not just in the classroom. And we want to know a little bit more about what's going on here at Bakersfield College. And so we've invited my friend Lydia here. Thank you so much for being with us. I appreciate your time.
You're welcome.
Can you tell us where we are now? Because we used to be next door, and now it looks like the computers have changed a little bit. The class has changed. What's going on in this room?
So this is our architecture class. These are second-year architecture students.
Okay.
And they're learning how to create a full set of drawings for a commercial project.
Okay.
And so if you look at their screens, you're going to find that they have plans and they have details and they have everything that is going to be necessary to create a full set of drawings.
Right. And so when a student says, I want to be an architect, they got to have some CAD experience and they have to be able to draw architecturally, which is a very specific way of drawing, right?
Correct, absolutely.
So what are you showing the students when they first get in this class? What are the skills that they need to have?
We would like for them to be able to analyze things a little bit closer, and so this whole concept of math, of understanding a process and a method, and understanding sizes, I think it's very useful for them. And of course, that then becomes a space, right? A design space where we're looking at proportion and scale, and of course the square footage, which always ties back to math.
That's right.
How big is that space? Because that's going to equate the cost of the building, the cost of the permit, everything radiates from that size.
The cost of the project, that's right.
Correct.
Now, we heard a little bit next door about scale. Okay, so for someone who doesn't know what scale is of a project, tell us a little bit about what scale means.
So the scale is, there's different ways to analyze scale, but the scale could be the proportion of something, right? The equation of something that's smaller and as it translates to something larger. Or the scale of a building, of course, could be the size of the building. How big is it? Is it a 10,000 square foot building or is it a 2,000 square foot building? So you can look at scale in different ways.
Right. And the scale that we do a lot of times in the drawings, right, is
A
we can't
proportion.
obviously have a paper drawing that's as big as a house.
Absolutely.
So we're going to say on the paper 1 inch equals a foot, or 1 inch equals a yard, or whatever units you're using, so it really is a comparison of two different measurements.
Correct.
And we have a smaller version on the paper, right?
That is right. And for architecture, the most popular scale is 1/4 of an inch equals a foot. So 1/4 of an inch on paper equates 1 foot in real life.
Gotcha.
So if you were to take a scale, which we actually have a tool called a scale, you can measure on the paper, and every 1/4 of an inch would be equivalent to 1 foot in real life.
Oh, good deal.
And the computer will allow us to do that too.
Right. So again, the computer's doing a lot of the math for you, right? But show us a little bit about these things that you have here on the computer. What kind of drawings are we looking at specifically here? And what maybe does the student have to keep in mind mathematically in order to make sure these things make sense? Because of course you could make some crazy drawings, right? But we want to make
Correct.
sure it makes sense in your whole overall project picture.
So today we're going over floor plans, and a floor plan is basically a look at all of the walls and all the doors and all the windows in a building. And we're trying to add dimensions, which once again tie all back into math. So we could see the distance from the door to the window, the distance from the window to the wall, and we can calculate how big these, the square footage of these buildings are. And then, of course, we have to tie these into notes. So for instance, in our restroom, we have to make sure that all of the details of an accessible restroom, which means a person on a wheelchair can come in and utilize this space and have the freedom to be able to come in and come out. So there's a lot of information that ties back into the plans. And it is a lot of fun. I think if you look at what students are doing, their projects are tying it into the real life. So this is actually exactly what we're doing here is they're learning something that they're going to be able to put into practice out in the real world and then hopefully be able to make a good living out of that.
And so there's so many factors, it sounds like to me. You have not just the fact that the window fits in the square on the wall, right? But you have to deal with codes and regulations and so that the building doesn't fall down, right? You can have a
Absolutely.
wonderful drawing, but we have to make sure that it really is a sound thing. So lots of math going on. If
Correct.
a student was coming to you and going to be in your class, what kinds of math skills would you like them to have before they got here?
Well, we would want to make sure that they understand at least some basic multiplication, right? So understanding how to multiply this length of the room to, with this length of the room to figure out areas. Ready for areas, absolutely. And those are pretty basic things. I think you pick these up probably in elementary school, middle school, and so forth. But then they go on and they take other math classes, and it's not because they're going to be utilizing it so much on the plan, but because they need to learn how to analyze things. And I always tell students, math is like doing exercises for your brain. You have to be able to analyze and understand if something's going to work or not.
I totally agree. And I tell my students the same thing a lot of the time. It's not just the problems. It's not just doing 10 problems in one way.
Correct.
We're solving problems. We're learning how to problem solve in our brain. We learn this specific skill, and now we have to apply that skill to a new set of information. So it sounds like that's exactly what's going on in here. Wow, awesome. Super cool. Maybe I'll have to sign up next week for this class. Sounds kind of fun. We have one more time to see some things going on here at Bakersfield College, but I know there's also some problems to do back in the studio. We'll be back with our last segment in just a bit.
All right, always a lot of great classes out at BC, and nice to see the students what they need to do as far as getting into the world of architecture. And we always have been lucky enough to have some architects on the program as well. In studio, we have Deborah, a 6th grade student from Ronald Reagan Elementary, and we also have a special guest with us now. Deborah, who is next to you?
This is my older sister, Donia.
All right, and Donia, how are you today?
Hello, I'm good. How are you?
You're a student also.
Yes.
But you're not at Reagan Elementary.
Not anymore.
Why don't you let everybody know where you go to school?
I go to school at Stanford, but for now, classes have been temporarily moved online, and so I'm here in Bakersfield with my family.
All right. And what are you studying at Stanford?
I'm studying biochemistry.
All right. And so when you study biochemistry, what is the goal when you're through at Stanford?
I'm honestly not 100% sure yet. I might want to go into industry. I might want to do consulting for a few years. I think possibly long term I want to go into clinical practice.
Now, do you think getting into Stanford, you were able to do that because of your middle school years, your 6th, 7th, and 8th grade teachers, and their influence they had on you?
Definitely.
Oh, okay. I'm just glad you got it. Okay. So that's nice to hear that you're doing well with everything there. So this is going to be fun because we're going to have sisters work on a problem. All right? So girls, go to the board. Each of you grab a marker. We're going to give Cindy a little break over here. Okay. Cindy, you can come over and hang out back here. And here's the problem for you two girls. All right? So you're not going to write on this. I'm going to give you a clear board to work on. What is the smallest number that can be written as the sum of two squares in two different ways? Now, Deborah, when we're talking about the sum, what does that tell you?
Add.
You're going to be adding, right? Two squares, so you're going to take a number and square it.
Okay.
Like 2 squared is
4.
4. 5 squared is
25.
So you're familiar with squares.
Yeah.
All right. Donia, you're familiar with these also, right?
Yeah,
Not
a little.
Okay.
Yeah.
So you have to take 2 squares, 2 numbers squared, add them up, and they have to add up to a number. And then you have to find another 2 squares that add up to that same number. Now, if you get something like in the hundreds, it's not going to work because we want the smallest number that can be written as the sum of 2 squares 2 different ways.
Okay.
Are you girls ready for this?
Yeah.
All right, let me give you a clean board. As you're working on this, explain what you're thinking and doing as you do it. All right,
Okay.
go.
So we know it's not going to be 2 because 2 with 2 is 4, and nothing else squared is going to be 4.
Okay, do you want to make a list of all the squared numbers?
That won't get squared.
So let's go like 1, 2, 3, 4, 5, 6, and then write their squares.
Okay. 1 with 1 is 1. 4. 9. 16. 25. 36. Let's do 7, 8, and 9 also.
You want to do 7, 8, and 9?
Yeah, to be safe, probably just go to 10 or 9 or 10 and maybe start with that and see how you work out.
And then 64. 81. 100.
Okay. Now what do you want to do?
So let's square them to different numbers. So not just squared, like another exponent, like to the third or to the fourth.
Why would you do that?
The question.
Wait, right now? Okay, so now what we want to do is find 2 of these numbers. So something plus something equals a given variable. And then we want something else plus that number or a different number to give us the same variable, right?
Yeah.
So now we want 2 numbers that add up to a third number that you can make adding 2 different numbers. So let's try this part in the beginning. So let's try 4 and 1. What number do you get? 5. Can you get 5 by adding any of the other numbers together? No. Okay, so what do you want to do now? So maybe erase this. Okay, try 4 and 9 maybe?
Would be 13.
Okay.
Which
probably not.
Then we have 9 and 16.
Okay, do you want to try like 4 and 16 or like 1 and 16 maybe?
Right, because they don't have to be
They don't have to be
consecutive
consecutive
square numbers. They can be any two together.
So maybe try 1 and 9. Or that would be 10.
Yeah,
it
that
wouldn't
would be
work.
10.
Okay, what about 1 and 16? 17.
17, 4 and 16.
So, okay, since we're starting with 1, maybe let's make it easy on ourselves and just add it. So 1 and 4 is 5, can't do it. 1 and 9 is 10.
You can't
1
do
and
that.
17. What about
Yeah.
17?
That
No.
probably wouldn't work.
What about 26?
That might work with something
Okay,
else.
how can you make 26?
You could do, let's see.
You could do 16 and 4 and 1. Could it be the sum of 3 numbers?
No, only 2.
Okay, so let's do 1 and 36. So 37 you can't. Can you?
No. No, you can't.
No. And, okay, just to make it easier, you probably can't with the rest. Okay, let's
Well,
try.
Don't give up so easily.
Oh, okay.
Okay, so you went 1 and 36.
Okay.
What
do you
about the
wanna
next
do
one?
1 and 49?
Would be 50.
Mm-hmm.
We could do,
What 2 numbers can you add up to make 50?
let's do 20. Oh, that would be, we would have to have 14 for that one. We don't have. We need 25 for that one. We don't have.
You can't do it.
Well,
Yeah, you can't do that one.
you're halfway there.
Yeah. Okay. Do you want to try?
Because 1 squared and 7 squared equals what?
50.
Okay, so in your first thing up at the top, right, you can put 1 squared plus 7 squared.
Do you want to put it on there?
Yeah, just go ahead and put it in the form you've got there. And together, what does that equal up to?
15.
Right, that's up to 50, right? So put 50 in the triangle. Now put 50 in the other triangle, because you know you have to get the same number.
Yeah.
What 2 numbers can you add to make 50?
So if we won, this one would be 49. This one would be 46, 41, 34, 25.
Ding, 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 ding. So 5 squared and what?
5 squared.
There you go. So 5 squared and 5 squared gets you 50 again.
Yeah.
So do you see how that works?
Yeah, I didn't know we could redo it.
So you could use the same one twice, but that's using it 2 different ways. Great work by the sisters right there. We do have one opportunity to head back out to BC and see how they're doing with Scott and the rest of the gang.
How much more cool stuff can we do here at Bakersfield College? We're about to find out, because there's some really, really neat things that we're going to be able to show you that our friend Darren Willis has got going on here. After you do some drawing and after you do some architecture, you get to make things.
You can actually make stuff
You
from
can
the
actually
CAD
make
files.
stuff. That's it. So what you got in your hand, first of
So
all?
we've got a dial caliper
Okay.
because we need to measure things very close tolerance. The dial caliper measures to the nearest thousandth of an inch. And
a little bit more precise than a ruler.
A little bit more precise than the scale or the tape measure.
Yeah.
I needed to measure the material here to a very close tolerance because the laser needs to focus properly in order to cut.
Okay.
So the file on the screen is a CAD file that we just made next door.
So you're going to cut that design
And we're going to
into
cut
the wood
Superman logo
with a laser.
out of the MDF. Yep,
Oh,
because
man.
I was able to tell it the material and tell it the thickness. It's able to do the speed and the power calculations.
Right.
And here we go.
Here we go. Wow. And so a student made this design, is that correct?
So this is a student drawn, an image he found on the internet. And,
Okay.
It goes fairly quick.
Yeah, it does.
There's a servo motor that controls the cutting. And it's 65 watts, which is impressive. If you think about a 65 watt light bulb, it's not really that bright.
Right.
But it'll punch through thin material pretty
But
quick.
it's awfully focused.
It's very
That's
focused.
probably the difference.
And then we work with a company over on Mount Vernon Avenue that they have a 4,000 watt laser, so they can cut through half-inch thick plate steel with it, like butter.
Sure. Yeah. So the wattage is going to definitely make a difference.
Yep. And
That's amazing. And so a student can create a design,
Yep.
and they can actually see it come to life here. Yeah.
Yeah, it's nice to be able to print your work, but it's even nicer to build things. A lot of students don't have woodworking or metalworking skills. So to have computer skills, you can come in here and create just about anything you can imagine.
Yeah.
So that's for thin material cutting. And then we have 2 3D printers that we use too. When
Right,
the
and
students,
sure, that's all the rage. I mean, everyone wants to know about 3D printers. So what you were telling me earlier, we are actually making something from nothing, right? Start with actually a blank slate,
Sure.
and then you make a 3D image
Yeah,
or
so the
something.
machine will take your 3D CAD file and it will slice it, and some of them are artistic
Hey,
models.
the piston cup, there
like
you
the
go.
piston cup or our little owl here, and some of them are more mechanical. Well, this is one of the mechanical projects we do in my SolidWorks class. It's an arbor press. The students have to design all the pieces have to fit together, there's tight tolerances, and then it actually moves up and down because all the pieces interlock and have connection.
Sure, yeah.
For this part here, if there's a shaft and it's supposed to spin, we have to talk about tolerance and how much clearance is there between the hole and the shaft, how much clearance is there between the groove and the dado at the bottom there, the dovetail, so that things move when they're supposed to and then don't move if they're not supposed to.
Those are
And,
two very specific things you got to
yeah.
make sure are correct.
And then depending on the student's ability and interest, I mean, we had some engineering students that wanted to make a prosthetic hand. So this is an actual prosthetic hand that we're able to send to places where maybe someone can't afford a real prosthetic, and this will last for years. The material is like Lego material. It's bio-friendly, and if something breaks, it's very quick and easily replaced. We just print out a new part. So there's all kinds of things that we can do with the technology. It is pretty cool stuff.
No doubt. So a student has a design. When you give them an assignment for something like this on a 3D printer, do you have just some parameters and say go for it, or do they pull a design and have to?
No, generally we have open-ended problems so that they get to be creative. A lot of the introductory work, there's not a lot of creativity because we want to make sure they have the skills. But once they get to the point where they can be a little independent, and it only takes about half the semester, they can be designing their own stuff and laser cutting it. And by the second class, they're designing their own products on the 3D printer and then producing them and prototyping to see if they fit well, if they function, if they slide, if they have the characteristics they're supposed to.
So they really are solving their own problems and coming up with their own ways of doing that. And I'm sure you see all kinds of different perspectives from different students because they all have a different way of looking at it with the same basic skills, right?
Yeah, one of the ones that I like to show off is this one. It was a student that designed a pizza cutter.
Ah, right.
And I mean, it looks really interesting.
Sure.
When you look at the profile, but then when you pick it up and feel it, you realize, well, this is terrible. This doesn't feel very good. And then another student had a nice design, and the design was very cool, but then when she printed it, she realized that she had made the bars too thin.
Right.
So it snapped.
Sure.
But she was able to take that and then improve on it to get the second iteration in a much improved design.
Yeah.
And that's just awesome because you would never see that on a piece of paper if you printed out your CAD drawing.
Right, right. And we certainly want to know about those tolerances before you print off 1,000 of them to go sell in the store or whatever. We want to know that they actually work.
Sure, before we make a mold or we have tooling made and spend thousands of dollars to produce a product to find out it doesn't work, that's kind of depressing. So we want to avoid that.
Hooray for prototypes. Man, we have enjoyed our day so much. We would like to present you with the official Do the Math tile that we like to give to our guests. And who knows, maybe there'll be some kind of a laser or 3D image printing of this by the time we come back next time. Thanks so much for your time.
With honor. Thank you very much.
Man, this is such a neat deal. And the range of things that can be built is just amazing with those skills, you know, in the background, knowing that they have to come in with certain math skills, but also be able to take instruction. And the best part about it, as I saw in the other room, there's some collaboration happening, because projects don't just come out of one person's mind. Gosh, what a great time! We were grateful to be able to be out here at Bakersfield College, seeing what's going on in the lab, seeing what's going on, making real things. Hey, that is some math in the real world. Back to the studio.
All right, thanks for that, Scott, and also thank you to the staff out at Bakersfield College for doing some great work for Deborah and Donia. We're going to award you girls with a couple of tickets to CSUB Athletics, any sporting event that you would like. Since you're visiting from Stanford, you can go visit CSUB and maybe catch an athletic event going on right now. So, Deborah, did you have fun today?
Yeah.
Did you learn something today?
Yeah.
Good. Donia, did you have fun today?
Mm-hmm.
That's all we want. Have fun here on Do the Math. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.